and we're going to be looking at the triangle inequality. Not every group of 3 segments can be used to form a triangle. So you've usually thought of all it takes is 3 lines to form a triangle. But what you're going to learn in this part of the chapter is that not every 3 segments can actually form a triangle. So in this example, or this diagram, if you notice, this side measures 2 units, the bottom measures 5 units, and this side measures 2 units. These 2 sides will never connect. They're not long enough. It is too short, so this will not form a triangle. In this case, the bottom length is 5, one segment is 3, the other one is 2. They don't connect either. And if you take 3 straws of different lengths and you perhaps measure them, make the bottom straw 5 centimeters and the side straws 2 centimeters, you will notice that there's no way to connect the 2 straws that are 2 units long. Same thing here. There's no way to connect the 2-unit straw with the 3-unit straw. But if you have a straw measuring 5 centimeters, another one measuring 4 centimeters, another one measuring 2, you'll notice that you can form a triangle. Now, this leads to the triangle inequality theorem. We're going to go ahead and read that official theorem. The triangle inequality theorem says that the sum of the lengths of any 2 sides of a triangle is greater than the length of the third side. So side length AB plus BC has to be greater than AC for a triangle to form. So for example, if AB was 5 and BC was 3, AC would have to be less than 8 because 5 plus 3 is 8 and AB plus BC has to be greater than the third side. So this would have to be anything less than 8. For example, let's say it's 7. That could be a triangle. If AC was 8, it would not be a triangle. It would not be able to actually close. It would look something like this. The bottom 8 and then this side's 5. The other side is 3, and you notice there's no way to make them connect unless you draw them longer. And it's very important to notice that in this theorem, it's any 2 sides of a triangle. So if we add AC and BC, it has to be greater than the third side, AB. So 7 plus 3, yep, that's 10. It's greater than 5. It works. AB plus AC has to be greater than BC. 5 plus 7 is 12. That's greater than 3. Yep, that works. And the first one worked. So when you add 2 sides of a triangle, it always has to be greater than the third side for it actually to be a triangle. Let's look at find possible side lengths. Here it says a triangle has one side length of 12 and another of 8. So this is 12 and then it has another side length of 8. We want to find possible measures for the third side. Well, we know that 12 plus 8 has to be greater than the third side. These 2 sides added together has to be greater than the third side for it actually to be a triangle. 12 plus 8 is 20. So that third side has to be less than 20 because 20 has to be greater than the third side. So x has to be less than 20. We'll call this missing side x. Now, since it's any 2 sides actually, x plus, let's separate this, x, which is the missing side, plus 8, x plus 8 has to be greater than 12. If we subtract 8 from both sides, we get x greater than 4. So x has to be greater than 4, but less than 20. And we'll do the other possibility. X, which is the missing side, plus 12, has to be greater than 8. If we subtract 12 from both sides, we'll get a negative number. So we don't have to worry about that because sides of triangles can never be negative. So the missing side has to be greater than 4, but less than 20. So anything between 4 and 20. So this third side could be 15, for example, because that's greater than 4 and less than 20. And we have, let me see. Okay, this is our last example. A triangle has one side of 11 inches and another side of 15 inches. Describe the possible lengths of the third side. So we don't know what the third side could be, but we know that it has these two sides added together have to be greater than the third side, which we'll call x, actually. If we add these two, we get 26. So 26 has to be greater than x, or this could be written as x less than 26. So this third side has to be less than 26. But again, it has to work for any two sides. So we have to also try x plus 11. That has to be greater than 15. If we subtract 11 from both sides, we get x greater than 4. So in this case, x has to be greater than 4 but less than 26. If we try this possibility, separate this. X plus 15 has to be greater than 11. If we subtract 15 from both sides, we get a negative number, so we don't even have to look at that possibility. So our final answer is that x has to be greater than 4 but less than 26. So one possible length could be 20, because 20 is less than 26 and greater than 4. And that's it for 5.5.